Okay, May, June 2023, paper 2, variant 1. Question 1. Which vector diagram correctly shows the force Z as the resultant forces of X and Y? So X, the force is directed upwards, and Y is directed to the right. The resultant of these forces would definitely be D. Okay, X was upwards and Y was to the right, so the resultant would be D. This is the head to tail method. Okay, it's the head to tail method. X was moving upwards and Y was to the right, so the resultant has to be somewhere up right. An object falls towards the surface of the Earth. The object is falling at a terminal velocity. What do I mean by terminal velocity? Constant speed. When do we reach a constant speed? When the air resistance and the weight are equal, when the air resistance and the acceleration of the object is equal to zero. Okay, there is no air resistance, there is no air resistance, there is air resistance and the acceleration of the object is negative, or there is air resistance and the acceleration of the object is zero. Yes, the acceleration has to be definitely zero because it's moving at constant speed. We have a speed time graph and we need to find the distance. Distance in a speed time graph is equal to area under the graph. So area under the graph is half times space times height. So half times 400 times 20, which would give me 4,000 meters. On Earth, a spring stretches 5 centimeters when a mass of 3 kilograms is suspended from one end. The gravitational field strength on the moon is 1/6 that of Earth. Which mass on the moon would stretch the spring by the same extension? So you need the same extension on the moon, but the moon has 1/6 the force on Earth. The moon has what? Has 1/6 the force or the gravitational field strength on Earth. That means for you to have a, or for the spring to have an extension of 5 centimeters, that requires 6 times the force. You need to multiply, you need to increase the force, you need to increase the mass basically by 6 times for you to have the same weight. Okay, for you to have the same weight, you actually need to multiply, you need to multiply the mass by what? By 6 times. So if the mass initially was 3 kilograms, you can multiply 3 times 6, that would be 18 kilograms. So 18 kilograms on the moon has the same weight as 3 kilograms on Earth. That's it. Okay? Okay. A shopkeeper pours rice. Sorry, a shopkeeper. A shopkeeper pours rice into a dish that hangs from a spring balance. He records the reading. A customer buys some pasta. The shopkeeper notices that the reading on the spring balance with just pasta in the dish is the same as it was with just rice in the dish. Just pasta and just rice. Which quantity must be the same? Definitely, we're talking about the weight, the force that is being pulled down. Which other apparatus does the student need to calculate the density? If I need the density, now I have found hmm, now I have found the volume because I've used the measuring cylinder and I can use the displacement method. How can I find the density? I definitely need the mass using a balance. A train is traveling horizontally in a straight line. A book is on the table. The diagram shows all the forces acting on the book. How is the train moving? That's really good. How is the train moving? To be honest, this is a really good question. If you have a frictional force, okay, to the right, you have a contact force upwards, you have the weight of the book downwards, okay, how would the train move in this case? The train would definitely move to the right of the diagram. The train would move to the right of the diagram. Why would it move to the right of the diagram? Because it is now accelerating to the right, and there's a frictional force to the right. Okay. Okay. Diagrams show four beams, each of negligible weight and freely pivoted. Which beam is not in equilibrium? Which of these beams is not in equilibrium? Definitely the beam with some resultant moment. with some resultant moment. B is in equilibrium. Okay, 6 times 1 is equal to 3 times 2. This is also in equilibrium. 3 times 1 is not equal to 3 times 2. Probably it's C. Let's calculate D. 4 times 2 is 8. 4 times 1 is 4. 2 times 2 times 2 is 4. So 8 and 8 is also in equilibrium. So the answer would be C. An object of mass 1.2 kilograms is moving with a velocity of 2.0 meters per second when it's acted upon by a force of 4 newtons. The velocity of the object increases to 5 meters per second. For which period of time does the force act on the object? This is a question you can actually solve this question using two methods, either using the impulse equation or using the acceleration or force equals mass times acceleration equation. Both would give you the same answer. I would actually use the force times time, the impulse, which might be a bit easier for this case. Equals mv minus mu. Force, we have the force, yes, 4 newtons times the time, we do not know the time, is equal to the mass, mv, 1.2 times 5, okay, it's in the same direction, minus 1.2 times 2. To find t, it would be quite easy, 1.2 times 5 minus 2 over 4, and this would give a final answer of 0.9 seconds. Which row about the change of energy in the energy store must be correct? Process, water pumped up to high altitude. Okay. The energy stored when the water is pumped upwards, the energy stored is gravitational potential energy, which is correct. Okay. And the change in energy stored increases. Okay, so this is actually the correct answer. Why? Because as you move the water upwards, what happens? The gravitational potential energy increases. The gravitational potential energy increases, and this energy is actually stored inside the water. A woman of mass 50 kilograms has 81 joules of kinetic energy. What is her speed? How can I find the speed using the equation? Kinetic energy equals half mv squared. How can I find the speed? Well, kinetic energy is equal to 81. Half times 50 times v squared. Half times 50 is 25. Okay, 81. V squared, we can just divide 81 divided by 25 and then square root the V, okay, square root 81 divided by 25. This would give a final answer of, let's calculate it, 1.8, around 1.8 meters per second. A child runs up a set of stairs 4 times. The time taken for each run is recorded. Which time is measured? Okay, when the child's use of power is greatest. How can you increase the power? By decreasing the time. Power equals energy over time. So whenever you decrease the time, the power will increase. A dam holds water in a reservoir. The height of the water is 15 meters. The density is 1000. What is the pressure? How can I calculate the pressure? Pressure equals rho GH. Pressure equals rho GH. In which rho is the density? 1000 times G, 9.8 times the H, which is the height, 15. Okay, this would give a final answer of around 150,000 pascals. I know that you have calculated it using your calculator. It's a bit, it's slightly less than 150,000, but you can just round up. A student uses a microscope to observe pollen moving on the surface of water, which is the Brownian motion. Which statement describes the reason for this movement? Water molecules are moved by microscopic pollen grains, or water molecules are moved by pollen molecules, or microscopic pollen molecules are moved. Yes, this is actually the correct one. Okay, because the pollen grains, what happens to pollen grains? They get bombarded, they get hit, okay. The water molecules collide with the pollen grains. It's not the other way around. Okay, it's not the other way around. So microscopic pollen particles are moved by water molecules. Okay. Which statements about evaporation of water are correct? Evaporation causes the remaining liquid to cool. Okay. It does cause the remaining liquid to cool. During evaporation, the more energetic molecules escape from the. Okay. Evaporation only happens at 100 degrees Celsius. This is wrong. This is boiling. Some. Okay. Some hot water is sealed inside a metal can. The can is in a vacuum in outer space. The hot water slowly cools down. How does the thermal energy escape into space? Only by radiation. Only by radiation in the space. What about through the metal? What about through the surface of the metal? Definitely through conduction. By conduction and then by radiation into the space. Diagrams show graphs of displacement. Which wave has the largest amplitude and highest frequency? Largest amplitude and highest frequency would definitely be A. Diagram shows a ray of light entering which calculation gives the refractive index. Refractive index would be the angle of sine, the angle of an air over sine, the angle in glass. The angle in air is not 50. It is not 50. The angle of incidence in this case has to be with the normal. Between the ray of incidence, between the incident ray and the normal line, which would be 40. 50, 90 minus 50 is 40 degrees. So sine 40 over sine 25. An object O is placed at the point P. Okay, an object O is placed at a point P. The object is now moved to point Q on the diagram. The object is now moved to point Q. This is the new position of object O. Which type of image is produced? Whenever the object gets closer to the lens, whenever an object gets closer to the lens, what happens to the object? The object gets larger. The object keeps on getting larger. Would it still be inverted or will it be upright? No, it will still be inverted. Why? Because it has not yet crossed the focal point. It has not yet crossed the principal focus. Once it crosses the principal focus, it will become upright and virtual, and it will be on the same side. Okay, it will also be enlarged, but okay, in this case, it has not yet crossed the focal point. Which diagram shows dispersion? Okay, that's quite easy. Dispersion, Roy Biv, right? Red has to be on top. Red has to be on top, and violet has to be on the bottom. In this case, B is correct. D is wrong. Why? Because the violet does not refract this way. Even if it does refract this way, it wouldn't continue in a straight line. It has to refract even more. Actually, in this case, violet is moving on the normal, which is very wrong. So D is wrong, C is wrong, A, no dispersion actually occurred, so they are all wrong. The only right answer is B. Visible light has wavelengths in the range of 4.0 times 10 to the negative 7 to 7 times 10 to the negative 7. What is the range of frequencies? How can I find the frequency? Well, that the speed we know that the speed equals wavelength times frequency. To find the frequency, I can say speed over wavelength. So I'll need to do two calculations. Speed of light is 3 times 10 to the power of 8 over the first wavelength, which is 4 times 10 to the negative 7. And then the other calculation would be 3 times 10 to the power of 8 over 7 times 10 to the negative 7. Quickly, if we can calculate this, it would give me two answers, two very large answers, which are 4.3 times 10 to the power 14 and 7.5 times 10 to the power of 14. Yes, definitely the wavelengths, the frequencies, I'm sorry, have huge numbers, okay? Have huge values. Any frequency, any electromagnetic frequency must be huge. Student X fires a starting pistol, which produces smoke and sound. Student Y is standing 100 meters away and sees the smoke the instant it is produced. The speed of sound in air is 340 meters per second. What's the time delay? How can I find the time? Speed equals distance over time. So to find the time equals distance over speed, which is 100 over 340. 100 divided by 340 would be around 0.29 seconds. An unmagnetized piece of soft iron is placed close to a strong permanent magnet. What's the polarity of X? The polarity of X would be definitely S, South Pole. Direction of force on the soft iron. How is this soft iron pulled or pushed? Is it pushed or is it pulled? Definitely it is. Definitely it's pulled to the left. It will be pulled to the left. I have a plastic rod and a cloth. The rod becomes negatively charged. The rod becomes negatively charged, meaning that it gains electrons. It gains electrons. From where does it gain these electrons? Gains the electrons from the cloth. So the cloth becomes positively charged. This is the only case which would be right. Actually, the arrow, okay, the direction of the arrow is wrong. That's the problem. The direction of the arrow is the direction of the movement of the particles, in this case, which are the electrons. The electrons are the only particles that are able to freely move between any two objects. A wire has a uniform circular cross-sectional area. Which statement is correct? The resistance. Okay. The resistance of the wire is directly proportional to its cross-sectional area. I don't think so. The resistance of the wire is directly proportional to the length, yes, and inversely proportional to its cross-sectional area. This is definitely correct. The diagram shows the current voltage graph for a metal wire. What can be deduced from the graph? We have a current voltage graph. As the voltage increases, the current increases with the same rate. Can I calculate R? R equals V over I. At any point, we would have the same resistance. At any point, you would have the same resistance. For example, if the voltage was 5 and the current was, let's say, 1. When the voltage increases becomes 10, the current would be 2. If it increases even more, 15, okay, the current will be 3. So at any point, if you calculate the resistance, it would be 5 ohms. So the resistance will remain constant. The resistance must remain constant because it's a straight line. A battery is connected to a circuit. It's switched on for 1 minute. During that time, there is a current of 0.4 amperes in the circuit, and the battery supplies a total of 48 joules of energy. Which row gives the charge? And which row gives the electromotive force? How can I find the charge and how can I find the electromotive force? You can find the charge using one of two I actually have many equations, but let's use the easier of the equations. I equals Q over T, in which Q equals IT. I is 0.4 times the time, which is 1 minute, but you have to convert it to seconds. You have to convert it to seconds. So 0.4 times 1 times 60 would be 24 coulombs. Okay, so it's either C or D. How can I find the EMF? Okay, EMF, you can use several equations. You have several equations. You have the energy, you have the current, you have the time. So E equals VIT, for example. E equals VIT. In this case, V equals E over IT. Also, someone could say, well, V equals E over Q. Voltage is equal to the energy divided by the charge. They are both the same equation. They are both the same. So the energy now supplied is 48 joules divided by 24, which would be 2.0. 2.0. Okay, good. The circuit diagram shows two identical lamps connected to a cell in parallel. Which statement about the current in X is correct? The current in X. This has to be the largest current. It is equal, it is less, it is equal to the sum. It's equal to the sum in y and z. Definitely it's equal to the sum in y and z. Y, for example, if this supplied a current of, let's say, 10 amperes, okay, y, for example, might take 3 amperes and z might take 7 amperes, so the total current is still 10 amps. Soon connects the circuit shown which switches must be closed for the bell to ring without, again, without lighting the lamp. Without lighting the lamp, you need 3 and you need 1. You do need 3 and 1, definitely. Can I switch on 4? No, do not ever switch on 4. Why? Because 4 would create a short circuit. It would actually kind of break the circuit. Okay, so do not ever switch on an empty wire. 1 and 3 only. Question 13, AC generator. This is actually a harder question. Um, we have a generator and we have a uh, potential difference, okay, versus time graph. He needs to find what? Which diagram shows the position of the coil at P on the graph? Okay, at P. I need to find the position of the coil. We have slip rings. These are called what? Slip rings. These, what do these slip rings do? They keep on rotating with the rotation of the coil. For an AC generator, you have to use the right-hand rule, Fleming right-hand rule, to find out the direction of the current in the wires. Okay, using the Fleming right-hand rule, in this case, you have the force directed upwards and the magnetic field from the north to the south using your Fleming right-hand rule. Again, your right-hand rule. The thumb is the force directed upwards. The first finger, which is the index, is facing to the right, and therefore the second finger, which is the middle finger, would be directed, okay, into the paper. So the current on the left-hand side of this coil is into the page, and the current on the right-hand side of this coil is out of the page. Okay, let's draw. As it's moving this way, let me remove this. Okay, as the current is moving this way, okay, it's connected. Okay, you need to look at this. It's connected to this side of the slip ring. Okay, it's connected to this side of the slip ring, and therefore this side would have a greater. Okay, this side would be positive. Okay, this side would be greater than y would be greater than x. In this case, again, in this case, y would be greater than x. Y would be greater than x. Let's look at the graph. What does the graph tell us? Okay, it shows the potential difference between x and y plotted against time. A positive value of potential difference indicates that x is more than y. Okay, that x, a positive value, indicates that x. So, for example, at this point, x has to be greater than y. And therefore, a negative value means that y is greater than x. A negative value means what? That y is greater than x, which is the case in the diagram. In the diagram, in this case, y is greater than x. So basically, all you need to do is choose one of the answers that would have the same setting for the slip rings. Again, not just for the coil if it's horizontal or vertical. You need to choose one of the answers which has the setting of the slip rings, okay, the same as the diagram stated above. If you check out the answers, definitely B and D are wrong. Most of you might have chosen A, okay? But the problem with A is what? That at this point in the slip ring, at this point with the slip rings, what's happening? X would be greater than Y. At this point, X would be greater than Y. And that's why at this point, X is greater than Y. No, we need Y to be greater than X, which is the same case, as the initial diagram. I know this question is quite hard. Honestly, this is one of the harder questions. if this question, if you had faced this question in your test, should you actually spend that much time in this question? No. Okay. If you actually faced this same question, if you had the same question, okay, what should you do? Leave it and then come back later. Please, please do not spend too much time on one question. It's only worth 1 mark. Okay. It's only worth 1 mark, which is literally nothing. Okay. 1 mark, 2.5% of your exam. Okay. You can just leave it and then come back later if you have time. Okay. Do not spend too much time on one trivial question. Okay. Moving on. Question 31. Question 31. We have an electron moving to the right, and we have a uniform magnetic field which is directed into the page. Okay. Direction of the magnetic field is into the page. Again, if you have an electron and a magnetic field, what do? You use your Fleming right-hand rule. Okay, you have to use the Fleming right-hand rule. Okay, again, Fleming right-hand rule. The electron, the first finger, again, the first finger, the index is the magnetic field. The second finger, which is the middle finger, is the direction of the motion of the electron. So the electron is directed to the right. The force on the electron now would be downwards. The force on the electron would be downwards, which would be towards the bottom. Towards the bottom. Again, using what? Using the Fleming, okay? Right hand rule, okay? Right hand rule. That's it. Yeah. Which statement about a transformer is correct? Transformers. There's an alternating current in the iron core. No, not in the iron core. There's an alternating in the primary coil, inducing a direct, no, not inducing a direct, it's an alternating current in the primary coil, inducing an alternating voltage in the secondary coil. What's a positive ion? A positive ion, you have to remove electrons. A negative ion, you have to add electrons. Which isotope, which of these, okay, is an isotope? It has to have the same number of protons. It has to have the same atomic number, which is B and B only. A radioactive source is placed near a detector, counted to a counter. Connected to a counter. 210 counts are recorded by the counter in 3 minutes. 210 counts. The background rate is 20. What's the corrected count rate? What is the corrected count rate? This is quite easy. All you do is, what should you do? The radioactive source, again, very simply, you just need to read it. Very simply, what do? A radioactive source is placed near a detector. 210 counts are recorded in 3 minutes. Okay? 210 counts are recorded in what? In 3 minutes. I know most of you want to do what? Most of you just want to say, well, 210 minus 20 would be 190. Is this right? No, it's wrong. Is this? No, it's wrong. Why is it wrong? That's what we used to do. We used to just yeah, that's all we have to do. Just minus, okay? 210 minus 20, and that's it. It should be 190. Is that right? No, it is wrong. Why? Because 210 counts are counted in what? In 3 minutes. Did he say that the count rate is now 210 counts per minute? No. He said it's per what? 3 minutes. So actually all you need to do is what? Divide it by 3. So 210 divided by 3 is actually 70. Now you can minus 20. 70 minus 20 would be 50 counts per minute. It's a really interesting question. Please try to solve it again. Okay. It's a really, really interesting question. The background count rate measured by a radiation counter is 40 counts, okay, per minute. Okay, 40 counts per minute. With the counter close to a radioactive source, the counter reading is 960 counts per minute. And the background radiation is 40. The half-life is 20 minutes. What's the counter reading in 1 hour, 1 hour later? 1 hour later. 1 hour later is 60 minutes. 1 hour later is 60 minutes. So very simply, what do? 60 divided by 20 minutes means 3 half-lives. 3 half-lives. So basically, I will divide by 2 3 times. Can I divide 960 divide by 2 3 times? No. You must minus the background. Okay, all you have to do is what? Minus divide, plus minus, okay, divide plus. So you have to minus the background radiation, and then you keep on dividing. In this case, you will divide by 2 3 times, and then you add, okay, then you add the background radiation again. So 960 divided by, 960 minus 40. I just said it. 960 minus 40 is what? Is 920. 920, you can divide the 920 by 2 3 times. 920 divided by 2 is 450 plus 10 is 460. Divided by 2 again is 230. Divided by 2 again is 115. 115. Then you have to add the 40 again, which would give you a total of 155 minus divide plus. Okay, whenever you have background radiation, minus divide plus. Which planet in our solar system? This is a really interesting question. Which planet is the nearest to the sun? My very excellent Mercury. What is the nature? Rocky. Okay, Mercury is the nearest, and the nature of it is rocky. A space station orbits the Earth at a distance of 7,000 kilometers from Earth's center. It makes 15 orbits every 24 hours. What? Every 24 hours. Okay. What is the speed? Okay, we know the orbital speed. Speed equals what? Speed equals 2 pi r over 2 pi r over t, in which r is the radius. Okay. It is the radius of rotation, and t is what? T is the orbital period. Okay. You need the final answer to be in kilometers per hour. Kilometers per hour. We have the distance in kilometers, and we have the period in 24, okay, hours in hours. It makes what? It makes 15 orbits. It makes what? 15 orbits every 24 hours. So actually, 2 pi r, you will multiply 2 pi r divided by 15. Why? Because it makes 15 full rotations in what? In the same amount of time. 15 full rotations in what? In 24 hours. So basically, 2 pi times 7,000 times 15 divided by the period, which is 24 hours. This would give me a final answer of around 27,000 kilometers per hour. 27,000 kilometers per hour. Which nuclear reaction powers a stable star? Nuclear fission? No. Nuclear fusion of krypton? No, definitely of hydrogen. Which stages in the life cycle of a star are listed in the order that they occur? Okay, which stages are correct? Um, Interstellar, dust cloud, then stable star, then no, this is wrong. Okay, dust, then proto star, then stable star. Proto star, then red giant, then no. Red giant and white dwarf, then proto star, no. Stable star, yes. Then it becomes a red giant, yes. And then it becomes a white dwarf. Okay, and that's it.